Hello students, I am Neeraj Garg, a senior physics faculty of Narayana Educational Institution. Today we are going to discuss the JEE Mains memory based question paper which was conducted on 29 January morning shift. As this question paper is a memory based question paper, so there may be some difference in the problem language, or they may not be exactly the question that is being asked in your question paper. Okay, so let us start with the first question. Here the first question, as you can see, is the projectile was projected at an angle theta is equal to 30 degree, then find the ratio of kinetic energy at a starting point to the kinetic energy at the highest point. So obviously this question is from projectile motion, that is motion in 2 dimension, and this is the easiest question. What he is saying here, as you know, once the body is being projected under gravity, then there is no horizontal force on the body. So we know the velocity of the body in horizontal direction is going to be constant, isn't it? Now you are saying the body, suppose, is projected with the speed u here at an angle theta with the horizontal that given to be 30 degree in the question, and once the body is reaching to the highest point, as we said, there is no horizontal force acting on the body, so horizontal component of the body is going to be constant. So we can say it is going to be u cos theta, rather u cos 30 degree, and cos 30 we know is root 3 divided by 2. Now as he is asking the kinetic energy at the lowest point and at the highest point, kinetic energy we do know very well, kinetic energy is equal to half m into speed square. Speed at the point of projection is u, and speed at the highest point as vertical component of velocity is becoming 0, so total velocity is only u root 3 by 2. So what we can say, kinetic energy at the lowest point to the kinetic energy at the highest point is going to be nothing but it is half m into u square divided by half m into u square cos square theta. So definitely it is going to be sec square theta. So once we are writing sec square theta, and that is simply sec square 30 degree, and that is what you are going to write. It is square of 2 upon 3, that means it is going to be 4 upon 3. So that is going to be your answer for this question. That means this answer is C here. Is it okay? Hopefully. Now let us go for the next question. As you can see, again this question, point O and 2 long wires are kept in the same plane such that point O lies at the middle of the line. Then magnetic field at point O due to the current I flowing in both the wires is. That's the simplest question on the magnetic effects of current, and that too is using the definition of how to find the magnetic field due to a straight current carrying conductor. We know well, if there is a current carrying conductor carrying some current I, and if you want to find the magnetic field at some distance r from here such that the extreme ends of this conductor are touching these 2 points, let us say this angle is going to be alpha and say this angle is going to be beta. We know well the magnetic field because of this is given by B is equal to mu 0 divided by 4 pi. Okay, it is I divided by the perpendicular distance r into what we are writing, sine alpha plus sine beta. That is the general formula for getting the magnetic field at any point from this wire if its length is a finite length. But what the question is asking here, he is saying there are 2 long wires. Long wires, if you see one wire here, so let us say this wire is like this, and there is a point O somewhere here at the middle. The total distance, if I consider it to be here 2r, let us say be 2r. So this distance is what, r, and this distance is r. Here is saying kept in the same plane at the middle of the line. Here in the question, again, as I can say, it is a memory based question. You be sure in the options you can say there is some distance L here, but in this question they have not mentioned exactly what is the length here. I hope this 2r, the separation between the wires, may be given to be L. So if we consider this distance to be L, now the question is answers may be A, answer may be B also. It depends what length is given to be L. So here you can say exactly plane such that O lies middle of the line, but what is the distance between the segment is not clearly mentioned out here. If I consider the distance between A and B to be 2r, then I can say yes, my R over here is going to be L upon 2. One more thing you can see, this wire, if you see, suppose I say I am at this point here, my point O is here, another wire I am keeping a distance R, this wire is going to go to the maximum length. That means if I write alpha here, so alpha is standing towards what? You can easily understand it is standing towards 90 degree. But if you look for the angle beta, beta is like this. So what is my angle beta? Beta obviously is going to be 0. That means the magnetic field at one end of infinitely long wire, we can call this wire as a semi-infinite wire also. So magnetic field because of this wire, suppose I say this is wire number 1. So I can say B due to wire 1 is going to be how much? Mu 0 upon 4 pi, current is going to be I, distance is going to be R, one angle is 90 degree and one angle you can say is 0. So I can say sine 90 and sine 0. So what's the value here? That magnetic field is going to be now mu 0 divided by 4 pi, I divided by R. Another thing now you have to see, check the direction of currents that will decide the direction of magnetic field at the given point. If you see this wire number 1, as the current is going in the upward direction, so if you use the right hand thumb rule, then the curls of the finger will indicate the direction of magnetic field, keeping your current in the direction of thumb. That means if you consider the first conductor and see it in this manner, current is going in the upward direction, that means the magnetic field at point O because the conductor 1 is in the outward direction. So I can say yes, this magnetic field B is in the outward direction. Dot is a representation for direction in the outward sense. Similarly, if you see the second wire is also given to be a long wire. So if it is also going towards infinity, that means one angle is 0, another angle is going to be 90 degree. The same value you will get this also. If I consider this wire to be wire number 2, then if I write the magnetic field because of the wire 2, so B2 will also be equal to B1 as far as the numerical value is concerned. Okay. See the direction also beta. If I say this wire is going, the current is going in the downward sense, if you see the right hand thumb rule, then again the curls of the fingers are coming in the outward sense. That means the magnetic field because of the second wire is also going to be how much? It is outward. So direction of B1 and B2, B1 is in the outward direction and B2 is also in the outward direction. The net field at the point O will therefore be B is equal to B1 plus B2. That means it is the sum of these two. Now what you are writing, the sum of these two will simply be mu 0 upon 2 pi I upon R. As I said in this question, it is not clearly mentioning what length L is all about. So if you consider the distance between A and B to be L, then your answer is going to be how much? This is total distance is going to be L. So I can say R is going to be L by 2. If I write R is equal to L by 2, what is my value? It is mu 0 upon 2 pi into I upon L by 2. This cancels out. So what is that you are getting? It is mu 0 upon pi into I upon L. Or let us see simply just a moment. So it is I divided by L. So what should be the answer for this question? That means if you see this option, so accordingly this answer should be the right answer. But if you consider this distance as center to this distance is taken to be L, then obviously this distance is going to be now 2L. That means R if is taken to be L, your answer will be mu 0 upon 2 pi I upon L. Here you can see a block is sliding down an inclined plane of inclination 30 degree, obviously with horizontal as shown in the diagram, with an acceleration of g by 4. The acceleration of this body is given to be here, g by 4, that is the net acceleration. Find the coefficient of friction between the block and the inclined surface. As you know, the body is moving down the surface. That means the nature of frictional force is going to be kinetic frictional force. If it is a kinetic frictional force, direction of kinetic frictional force we know is opposite to the direction of relative velocity of the body. As this surface is taken to be fixed, body is coming in the downward sense, that means my frictional force will be acting in the upward direction. If you go for the free body diagram for this body, so this is the direction of my kinetic friction force. And kinetic friction force we know very well, it is coefficient of kinetic friction into the normal reaction of the surface. If you see the gravitational force acting on this body is vertically downward, that is mg acting in this manner. Normal reaction being perpendicular to the surface, here this is the normal reaction R. if I resolve my mg in these two directions, that is along the plane and perpendicular to the plane, if this angle is 30 degree, so this angle is also 30 degree, let me denote it by theta for the time being, take it to be theta. That means this force component will be mg cos theta. If it is mg cos theta, and this downward is definitely is going to be mg sin theta, that's there. Once we write this, as there is no motion in the vertical direction, that is perpendicular to the plane, that means what we can say, sigma, if I consider this direction to be x direction or downward as to be x direction and perpendicular to be my y direction, so what we can say, there is a net force in the x direction, but there is no force in y direction. As body is set to move with an acceleration g by 4, so net force along x direction is going to be ma, that is mg by 4. Now you write the free body diagram. As since simply you write sigma fy is going to be 0 because there is no motion in this direction, so this simply implies what? Your r is going to be mg cos theta. Once we get r, we are done with this fk. So we can write now fk is equal to mu k into mg cos theta. That is one thing, isn't it? In the downward direction, that is what we are considering it to be x direction. So if you write it x direction, so what is my net force in x direction is going to be m into acceleration in x direction is given to be g by 4. So we can write it as mg by 4. The moment I write it as mg by 4, but net force in x direction is simply how much? We can say it is mg sin theta minus mu k mg cos theta is equal to mg by 4. mg throughout cancels out. Theta being 30 degrees, so we can substitute the values now. 1 upon 2 minus mu k into root 3 upon 2 is equal to something like 1 upon 4, like this. So what you are getting? We can say it is now mu k root 3 upon 2 is equal to 1 by 2 minus 1 by 4. So what we can say it is 1 by 4. This 2 cancels with this here. So what is the value of mu k? So mu k in this case is going to be 1 upon 2 root 3. So let us see, is there an option given over there? So 1 upon 2 root 3, yes. So B should be the correct answer for this question. I hope you should understand what we are doing here. Okay, let us go for the next question now. Again, you can read this question as he's saying a car is moving on a circular track of radius 50 centimeter with coefficient of friction being 0.34. On this horizontal track, the maximum safe speed for turning is equal to. Now you know, whenever the body is moving, so you know it's a very well question on circular motion on a horizontal surface. You know, for a body to move on a circular path, definitely we need some centripetal force. And centripetal force, you know, is not a new kind of force, is a force which is being derived from all external forces acting on the body in the plane of motion toward the center. Since this body is moving on a horizontal track, so if you consider this body is moving on a horizontal track in this manner, so suppose at any instant I say my body as is showing is here is going to be this body here. This is my radius of the circular track, r. Okay, you know, if the body is moving on a circular track, there is some centrifugal force, if you look with respect to this frame, acting in the outward direction. This force will try to move this body away from the center. If the force is having tendency to move away from the center, that means there must be a frictional force acting towards the center. This force, again you can say, is going to be F static here, because this body is not sliding along this direction. If the body is not sliding in this direction, so the nature of force should definitely be static here. This static force definitely is going to provide you the necessary centripetal force to take that turn. What I can say? That means we can say Fs must be equal to mv square upon r if my v is the speed of this body as indicated over here. Once this velocity is v, Fs is this. Now you know, Fs is my static frictional force, but static frictional force is always less than or equal to limiting frictional force. What is my limiting frictional force by definition? Limiting frictional force by definition you are writing is mu s into r, that is coefficient of static friction into the normal reaction. On this horizontal surface, as very obvious from this diagram also, the normal reaction will be acting in the upward direction and mg will be acting in the downward sense. Again, as there is no motion in the y direction, so r must be equal to mg. Once I am writing r is equal to mg, just try to understand I am doing it v here, but v is in a horizontal plane, r is in a vertical plane, no problem. What we can say here, it is mv square divided by r is equal to mu s into mg. What we can say with a mm cancelling out. So here I can say it is less than or equal to, okay, if you want to write less than or equal to, that's better. So what is the value? You can say v is equal to, or rather again, less than or equal to under root of how much? Mu s into r into g. As we are getting from here v is less than or equal to this value, then all these values of the v are going to be the safe velocity which will provide you a circular turn on the surface. So if it is less than or equal to, very obvious, that means what is my maximum velocity should be equal to under root of mu s r into g. That should be the value. Mu s in the question you can see here is given to be 0.34. So now substitute the values, 0.34. The radius of the track is given to be 50 centimeter. That is, if I write in meters, 50 by 100, I can make it as 1 by 2 meters. G, if I say, is taken to be 10 here in the question given, take it to be 10 here. If I write 10 in this case, this should be the value. If I write this here, 2 into 5, and if you simplify this thing, 5 into 4 is 20, and 5, 3, 15, so it is going to be 1.7 under root. And 1.7 you can say 1.3 square, that is 1.69 nearly, so that means this value I can say is nearly 1.3 here. That means what is my maximum velocity should be v 1.3 meter per second. That means the answer should be C here. So if you want, you can write, because all the values in your SI, I can say it is 1.3 meter per second. I hope you should understand this question again, what we are doing. Okay, let us proceed for the next question. See this question, they are saying two resistors R and 3R are in parallel. Okay, find the ratio of power dissipated in them. Is the simplest question of your current electricity. But the thing is, we should not get confused, because sometimes students just simply remembering power is equal to I square R, or sometimes we are writing V square upon R. What we have to write, whether I have to write now power dissipated as I square R or V square upon R, you know very well. Whenever the conductors or the resistors are connected in the series, the current is going to be same in both the conductors or both the resistors. That means if conductors or the resistors are connected in series, I will use my power is equal to I square upon R, I square into R, so I can say my power will be proportional to R. But what the question is saying, as they are connected in parallel, if I write in parallel, you know one thing very, very simple. In parallel combinations, the potential difference across the conductors is going to be same. If I say one is going to be R, one is going to be 3R here. As potential difference between these 2 points V is constant, so what is the way to write your power dissipation? Obviously, P will be writing as V square upon R. So what we can say, since my V is a constant quantity, we can say P is proportional to 1 upon R. If P is proportional to 1 upon R, as he is saying resistors R and 3R, so we should write power dissipated in resistance R and power dissipated in resistance 3R. If I am writing, as you are saying it is inversely proportional to this, so I will be writing it as 3R upon R. So what are you going to get now? It is 3:1. Is there an option possible? Yes. Here we can say C is 3:1, so that should be the answer for this question. So it is a very easy question. I hope each and you should be able to solve this. Okay, let us proceed for the next question now. Here in this question you see in a meter bridge, as this question is from a meter bridge, experiment null point is found at a particular point for a resistance of 2 ohm and 3 ohm as is shown here. Then resistance X ohm is shunted on 3 ohm as is shown here. Shunting is done with the parallel with this 3 ohm, and null point shifts by 22.5 centimeter. So the most important thing for this question is what? He is saying it is shifting by 22.5 centimeter. The shifting may be away from the left junction or it may be towards the right junction. In which direction we have to move? I think it should not be given in the question paper, as again this is a memory based question paper, so somebody might have told the question. I hope this distance also should not be given in the question, because if I provide you L is equal to 40, then there is no need to give you 2 ohm and 3 ohm in the question. Giving this means these resistances as 2 ohm and 3 ohm here, we can easily calculate how much is the length of this L and 100 minus L. You know, your meter bridge works on balanced Wheatstone bridge. If I write it as a balanced Wheatstone bridge, then you all know I take these 4 resistances kept along the 4 arms of I square. Across one diagonal we are putting some potential difference. Let me say this is the point A, let me say this is the point B. At point A and at point B I am putting some potential difference. That too is not shown in the diagram, but I think they should be given out here. There must be some potential difference. It should be between A and B. So it has to be mentioned where I am keeping my potential difference. So being memory based, so there are some problems. So it is 2 ohm and this question in here it is given to be 3 ohm. As in the diagram it is very clearly indicated that this wire is of uniform thickness. So we should also mention the question, yes, this wire is a uniform wire. So if we consider this to be a uniform wire, you know very well R is equal to rho into L upon A as my area of cross section of the wire. L is the length of the wire. For the complete single wire, the resistivity will remain same. So what we can say, if resistivity is same, my area of cross section is same, that means if I write the proportionality, R is going to be proportional to L. Is it okay? If it is proportional to L, that means if I consider this length to be L and this length is going to be 100 minus L in centimeters, so I can write down 100 centimeter, because you know in meter bridge the total length of the wire is 100 centimeter, isn't it? Using this thing now, if I put a galvanometer in between, it is showing null deflection. That means the current here is going to be 0. The moment current here is 0, that means these 2 points are at same potential. If you do a bit of theory over there, then you know very well if I write this 2 ohm and this, the resistance upon this is going to be this divided by this. So you know condition for balanced Wheatstone bridge, the condition of, if I say balanced Wheatstone bridge, in this case if I use, let me write for the time being, it is R1, take it to be R2, I write this as R3, I write this as R4. So what we can say, obviously we can say this now, R1 divided by R2 is going to be R3 divided by R4. So that again is a very easy question for you to answer, but till here it is okay. I can find my value of L easily. It is going to be 2 divided by 3 is going to be now R3, as we said, is proportional to length divided by L upon 100 minus L. Hopefully if you solve this thing, which is obvious, it is 2L minus 2L plus 200 and is 3L. So 5L is equal to 200, that means L is equal to how much? Is 40 centimeter. So we got the value of L 40 centimeter. So this is given here, L is 40 centimeter. Next point, that is what we have to understand in this question. The second resistance 3 ohm is shunted with a resistance in parallel, you know, in parallel combination, the equivalent resistance is going to be less than the smallest value. Okay, that means I can say yes, this resistance definitely is going to be smaller than 3 ohm resistance over here. If this resistance is becoming smaller, that means if my R2, suppose I call it now R2 dash, if R2 dash is becoming less than R2, as this distance is this resistance is becoming smaller, so this distance should also become smaller to get my balance condition satisfied. That is R1 upon R2, this resistance and this resistance, as you're saying R1 and R2. So what you have to do? You have to make, rather I can say now R1 upon R2 as R3 upon R4. I am decreasing my R2, so I have to decrease my R4 as well. So if R4 is decreasing, that means this point should be shifted towards right hand side direction. If it is shifted towards the right hand side direction, that means how much is my L1 and how much is my L2 now under the second condition. So now we say this resistance here, complete this resistance for the time being, I am writing it as R dash. If it is R dash, what we can write? It is 2 divided by R dash is going to be, now this length is going to be how much? As it is going towards right, it will become 40 plus 22.5. Down there it is becoming, it is 60 minus 22.5. If we are writing these things, the 40, 20 is going to be how much? 62.5 divided by how much is this now? 22.5 is making is 23, and how much is the value? 30, how much? 20, 40. So 37.5 if I am not wrong. Okay, just a moment. It is 37.5. Okay, 5, 5, 10, 7, 2, 9, 10, 3, 2, 5, 6. Okay, 37.5. If you simplify this, let us see what is the value. Decimal you can remove. The 625 upon 375. Is it divisible by 25? Yes, it is divisible by 25. 25 into 25 is 625. And how much is this value? 25 and 25 and 125. It is going to be 15 over here. If I write 15, how much is the value? It is 5, 5, 25. 5 divided by 3, we can get this value. So what I am getting now, that means 2 upon r dash, I write it again here, it is 2 upon r dash in this manner. That means now your r dash value is becoming how much? R dash is becoming 6 divided by 5. But you know, in parallel combination, if my resistance over here is x, r dash can be written as R1 R2 upon R1 plus R2. That is what everybody knows. So I can write now, it is going to be 3x divided by 3 plus x. That is my r dash. Once we write this here, so if you simplify this thing, I hope it's easy again. 6 into 3 is going to give you how much? 18 plus how much the value? 6x is equal to 15x. If I write this 15x minus 6x is 9x is equal to 18, so x definitely is going to be 2. So that means your resistance x must be 2 ohm. So out of these you can see yes, B should be the right answer for this question. I hope you should understand the main point or main click of this question. Shift should be in which direction? Should be on right or should be on left. That is the only clue for this question. So that question is again a simple one. Okay, let us go for the next question now. This next question is from wave optics, that is your Young's double slit experiment. Here we are saying in Young's double slit experiment, first minima is found directly opposite to upper slit. Directly opposite to upper slit means what? This y distance should definitely be nothing but what? D divided by 2, as you can see in the diagram. Once I am writing it is d by 2, then find d. He is asking lambda is going to be 800 nanometer and d is going to be 5 centimeter. I hope what again we can say it is a memory base, so there may be a problem. This distance should definitely be given to be much larger than this small d. Then we can solve this question in a simplest manner. If this condition you are considering, then you know what is my path difference for the light beams which are reaching at these 2 points. I can draw a perpendicular over here. Considering this to be large distance, if I make it a perpendicular here and I join this point from here to this point. Okay, for the clarity I just draw a separate diagram for you. Let us say this is slit number 1. I am indicating by circle, no issue, and this is what is going to give you slit number 2. So I write S2 and I write here is my slit 1 S1. Okay, what I am trying to say, if you want to find this is going to be large distance, capital D is much larger than a small d in this manner, and if you want to find the path difference somewhere at this point, so what we do, if we have to write this relation. What we generally say, if d is much larger, so you can do it by binomial expansion also, but in a simplest manner if I write, I drop a perpendicular here. So once we draw a perpendicular in this manner here, so this distance and this distance, I hope we can assume it to be correct, because you can consider this to be center of an arc, and if we take this distance and this and these distances from here to here are going to be equal, what is my path difference? If I denote it by n, is standard notation, this is going to be my path difference delta x. If this separation is given to be d here, and this angle if I consider it to be theta, now what we have to see here, if this angle is theta, then one thing we have to be careful. Since this distance is very long and I join this point here in this manner, Being these lines almost parallel, if this is 90 degree, we can say this angle is also going to be 90 degrees. So you all know well over here also, if this is theta, this is 90, it is 90 minus theta, that means this angle is also going to be theta here. So we know this part difference can be written now in the easiest manner, it is d sine theta. So we are trying to do it in a simple way. Otherwise, if you want to do it by binomial expansion, we can do that way also, but that is going to be lengthy calculations. Delta x, if I write d sine theta, but theta being very small as my capital D is a large value. So what we can say, we can approximate is going to be d tan theta also. The moment I write it is going to be d tan theta is nothing but what? This distance if I say is y, I can write it is d into y divided by capital D. In the question he is saying y is equal to d by 2. What is my part difference? Therefore, at this point where I am saying is my first minima, so delta x at first minima is going to be how much? It is d divided by capital D into y, that is d by 2. What we are getting? It is simply d square upon 2 times capital D. But you know by definition, if there is nth minima, my part difference is going to be 2n minus 1 lambda by 2. It is my first minima, that means this delta x must be equal to how much? Lambda by 2. If it is lambda by 2, so what we can write? He is asking you to find the value of small d. So small d can be written as how much? This 2 cancels out. We can write is lambda into capital D under root. If I write lambda under root, substitute the values now, we'll give you the option. What is my lambda? 800 nanometer. So we can write 800 10 raised to the power minus 9. D is given to be 5 centimeter. So we can write into 5 centimeter, 5 divided by 100 like this. If you write it is going to be this 800 cancels out. What you are writing? It is 4 into 10 raised to the power 10, I am taking it out here, minus 8 under root. If you take this 4 under root 10 to the power minus 8 is obviously it is 2 into 10 raised to the power minus 4 meter. Okay, but you checked your options, they are giving in the millimeter, so obviously it is going to be how much? 0.2 millimeter. That should be the correct answer for this question. It is there, yes, one option is given out here, the C should be the right answer for this question. Okay, I hope you can understand this is also easy one. Let us see the next one then. Now this is a question on your gravitation. What we are saying, two objects of equal mass. One thing, be careful, two objects of equal mass m are moving in a circular path of radius r. Because of their mutual gravitational attraction force, find the velocity of each particle. You know very well. Whenever again, as we said in the beginning, some question, that is what we were doing for the cycle or the object moving on a circular path, we said yes, what is my centripetal force? Here we are saying two objects are moving under mutual force. I think in the question they should mention there is no other force acting on the bodies. So we have to be careful. Again, repeatedly we are saying it is a memory based question paper. So some lines, some statements may be missing in the question, but that question can be answered only if we say yes, these two bodies are moving only under mutual force of gravitational attraction. Then I can say yes, what is the gravitational force of attraction on these bodies? We can find this way. And this gravitational force of attraction is providing you the necessary centripetal force for this object to move on a circular path. He is asking what is the speed of the particle. Again he is saying velocity, okay, no problem. We can say yes, the speed of this particle suppose is given to be v in this situation. The distance or the radius of the path given in the question is to be r. You know the centripetal force. The centripetal force is going to be how much? M into v square upon r. Easy. Once we write, and this centripetal force is provided from where? From the gravitational force. We can write this is equal to my gravitational force. By Newton's law of gravitation, we know very well that F gravitation is going to be how much? It is G, universal gravitational constant, into the mass m1 into m2 being equal, I can take it to be m square, divided by the distance with the two masses. And here the distance with the two masses, we have to be careful, it is going to be 2r. That is this 2r. That means this distance is going to become how much? It is 4r square. This gravitational force is equal to centripetal force. So what we can say? Simply we can write it is going to be m into v square upon r here. What he's asking to find the speed. So in this case, if I write this here, so equating these two, this m, this r is cancelling out from here. So my v square is going to be gm upon 4r. There should be g into mass of the body upon 4r. Under root is this value. So what is my option is there? Yes, there is one option, that is under root gm upon 4r. So that should be the right answer for this question. Okay. All right, let us go for the next question now. Okay, he is asking here the find coordinates of the null point. Null point means what? Where my net force on the particle or net force is going to be 0. Here you see it is a question from the electrostatics. Again, yes, you have to be careful in this question. First thing we know, electrical force cannot be 0. You see one thing, this charge is a positive charge. In the question you can see this is going to be a negative charge. If we go according to the direction of the electric field, from positive charge my field is directed away from the charge, for negative charge my field is directed towards the charge. That means between these two charges, both the fields because of positive and the fields because of negative are in the same direction. That means for net force or net E to become 0 is not possible between these two charged particles. Another thing is that if you go on the right hand side, my, if you say the positive field is going to be E positive in the right hand side direction, negative charge will attract, so we can say E negative on the left hand side direction. Similarly, if you go on the left hand side of this body here, I am just showing it here, in the left hand side positive charge will give you the field in this manner, it is E plus, and negative will give you the field in this manner, it is E negative. One thing is that yes, my electric field can be 0 on the left hand side, also it can be 0 on the right hand side direction. But to get my E 0, so you know, since at null point, if I am saying, so at null point what we are writing here, your E net must be 0, meaning simply E1 and E2 should be equal and opposite. You know, E is proportional to Q upon R1 square, and E2 I can write Q upon R2. Even if I consider, suppose I write it on the right hand side, let us try on the right hand side itself. If on the right hand side, let me say this is my Q1, take it to be Q1, take it to be Q2. So from second charge, I say suppose I am getting my null point at this point. So I am writing it here, this distance is R2 and this distance is going to be R1 suppose. What we are writing, that simply says Q1 upon R1 square should be equal to Q2 upon R2 square. That is what I am looking for my right hand side direction. If you see this question, Q1 is going to be more than Q2 numerically. So if Q2 is going to be more than numerically, so since what we are writing, Q2 is more than Q1, that simply implies R2 should definitely be more than R1. If R2 is going to be more than R1, then what can we say? If I am writing here, or you just write it Q1 upon R1 square is Q2 upon R2 square. Q2 is not less, just a moment. Q2 is given to be less, okay. Let us correct it. So I am just changing these values, okay. So now you come to the point, as I say Q2 is smaller in magnitude, Q1 is more, so I can write Q1 is more than Q2, no issue. If Q1 is more than Q2, so what we can say, if Q1 is more, so I can say definitely my R1 should be more than R2. I hope there is no confusion. It is Q1 I am writing by 4 Q0, Q2 I am writing numerically as Q0, Q1 being more than Q2, R1 should definitely be more than R2. As you can see from here, R1 is more than R2. Definitely on the right hand side, there is a possibility of null point. So if I write this distance, so what we can write now, R1 minus R2 is going to give you here, those in the question it is given R1 minus R2 is 12, and here we can say R1 upon R2 in the question you can find from here also, R1 upon R2 is equal to under root of Q1 upon Q2. Under root of Q1 upon Q2 is saying it is under root 4 upon 1, that means 2. So R1 is equal to 2R2. If I write R1 is equal to 2R2, that means R2 is equal to 12. That is what we are looking for. This distance already is given to you 2, R2 is going to be 12 here. So whatever the units are given to you, if it is centimeters, a meter, whatever it is, so it is going to be 12 units here. If it is 12 units here, so what is the coordinate where I am going to get my field to be 0 here? It is obviously, it is going to be x coordinate remains 24, y coordinate remains 0, so it should be 24 comma 0 should be the option possible here. So see here, okay, D is the possibility. So here 24 comma 0 is the coordinate where my net electric field is becoming 0. Okay, you can see this question now. A soap bubble of radius r and surface tension S is blown to double the radius. Find change in surface energy. Again, is a definition based question from the surface tension. You know, what is the energy of the soap bubble? The main thing here, we know surface tension S is equal to how much work done per unit area. So I can write now delta W divided by area. Here we generally write A as my effective area. Effective area means the area of the body which is in touch with surrounding air. If I say it is my soap bubble, so you can understand air is inside and air is outside also. As thickness of the bubble is almost negligible, that means this area effective is becoming how much? If this radius is taken to be r and this surface area is going to be 4 pi r square, that means I can write this as delta W upon 2 times 4 pi r square, inner surface and outer surface. So that should be 8 pi r square. If I write capital R, no issue, take it to be capital R. Okay, once we are writing this is going to be S. Whatever is the work done in forming this sphere of radius r is nothing but what? Its energy. So I can say yes, my energy of the soap bubble is going to be S into 8 pi r square. Isn't so simple? So I can write my initial energy is going to be this only. Now you're saying you have to blow in such a way so that my radius is becoming double. If my radius is becoming double, that means my U final will become S into 8 pi into my radius is doubled, so I can write it now 2 r whole square. What you are going to get now? Obviously it is what? S into 8 pi r square. Okay, let us take out to be common, S into 8 pi r square into 4 here. Difference of this energy is simply nothing but what? Is the change in its energy. That's what we are asking here. How much change in the surface energy you have to write? The change in the surface energy is going to be 4 minus 1 into S into 8 pi r square. What is this value? If I write 4 minus 1 is going to be 24 pi S square. So I write it as 24 pi S r square. So 24 pi S r square, yes. A is the right option for this question. Rather, it should be the right option for the question. This question now you can see there is a square loop of length L. A very small ring of radius r is placed at the center of the square. Find coefficient of mutual inductance. That is obviously a question based on electromagnetic induction. He is asking mutual inductance. If you want to find the mutual inductance, you know one thing, if there are two coils, one carrying some current I, and if I keep another coil in front of this, let us say some current I is flowing in this manner, it is I1. Then because of this there is a magnetic flux is generated and this flux will pass through this coil. If it is passing through this coil, how much is the change? So now if I change this current or I change the separation, anyhow if I change the flux here, then there will be an induced EMF. That is what my Faraday's law of induction are saying. How much the change in the flux here? So I can say the magnetic field on 2 due to 1 if I know, so I can write the magnetic field over here at point 2 or is ring 2 due to field 1. If my area of this is going to be something like A2, how much the flux associated with the second is phi 2 due to 1 is going to be magnetic field at 2 due to 1 into the area of this loop here, that is A2. Okay, once we write this flux, then what the definition is saying, this flux should be equal to the mutual inductance of the 2 due to current in the 1 into the current in the primary, that is what you are writing I1. So what we are writing, mutual inductance of second coil because of the first coil is equal to, and you know theorem of reciprocity also says M21 is equal to M12. So not a big deal. I can write M21 is going to be now flux of 2 due to 1 divided by the current I1. So the only task in this question is what? See here, what he is saying is a very small ring. In case of a small ring, I can consider within the radius of this ring, field can be assumed to be almost uniform. If my field is going to be uniform, then only I can write my flux as B into area of this ring. Let us take for the time being, here he is saying it is radius is R, okay. This radius is given to be R here, so we take it as R as my radius. There is a current carrying conductor of length L. Again, you know how to find the magnetic field, right? In the beginning we said, if there is a current carrying conductor, then how do we find the magnetic field at this point? We know if this perpendicular distance is going to be how much, that R perpendicular is L by 2. Okay, what is my magnetic field at the center? So B at the center due to wire number 1, if I am writing the due to wire number 1 is going to be again, you know, mu 0 upon 4 pi I, the current in this coil, call it as I1. Because of this we are trying to find the mutual inductance of the second coil. So I1 divided by the perpendicular distance. Perpendicular distance here is going to be L by 2. So I write L by 2 in this way. So B is mu 0 upon 4 pi I1 into 2 upon L. If you say, I can just simplify it in this manner, it is mu 0 into I1 divided by 2 pi into L. That is now the magnetic field at the center of this circle due to one wire into here I have to write sin alpha 1 plus sin alpha 2. See these angles, if these angles are going to be 45 and 45 here, so I have to write now into sin alpha 1 plus sin alpha 2. Just a second, okay, just a moment, okay, this part. So again let us come back to the point. The magnetic field at the center is mu 0 upon 4 pi I upon R into sin 45 plus sin 45, that is this value. Sin 45 is 1 by root 2, 1 by root 2 is root 2 only. So what is this value? It is mu 0 upon 2 pi, it is I1 divided by L into, already we said it is root 2. So I1 upon L into root 2. That is going to be the magnetic field at the center because of one wire. What is my total field at the center? So B at C, if I write net, because these 4 wires are generating the field both in the outward direction. Again you can see right hand thumb rule, because of my thumb it is indicating always my field is in the outward sense. If my field is in the outward direction, so what you are going to write now? Total field is 4 times this field. So I write 4 times mu 0 upon 2 pi into I1 upon L into root 2, isn't it? So what you can say, if you want to simplify it further, so we can say it is going to be mu naught divided by pi into I1 divided by L into 2 root 2. That is going to be this. This is the total field within the circular region, and as my R is very small, so within the whole complete region we can assume my field is going to be uniform. So what is my flux? So that means the flux over here, if I write the flux through this ring due to this, so I can write phi 2 1, because it is what I am considering one ring, I am considering as my second element 2. Phi 2 1 is going to be, it is B into B of at 2 due to 1 into the area of the 2. Area of the 2 is going to be pi r square. What is my value here? So now you are writing it is mu 0 upon pi I1 upon L into 2 root 2 into pi r square. But what we said in the beginning, by definition flux is going to be mutual inductance into the current over here. So I can write this is going to be nothing but what? Mutual inductance of the secondary due to primary into its current in the I1. This I1 can get rid of. So what is my M21 is mu 0 upon pi I up this pi r square 2 root 2 upon L. So there is no option anyway in this question, no option is given. So I hope you can understand what is my mutual inductance. I write my answer here. M is going to be mu 0 upon pi into 2 root 2 pi r square. Pi if you want you can cancel out. So we can cancel out this mu 0 upon pi r square here. So pi we can get rid of. Okay. So this is cancelling. So mu 0 r square into 2 root 2 mu 0 r square 2 root 2 divided by, let me write clearly here, 2 under root 2 to mu 0 r square 2 root 2 divided by L. That should be the coefficient of mutual induction for this loop. Okay. So that is what I say to find coefficient of mutual inductance. So as in this question again we are saying memory base. So quite possible students may not be remembering what is the value of M here. So we get M is equal to mu naught r square 2 root 2 upon L should be the right answer for this question. I hope you should understand yes how to approach flux, mutual inductance into current. How will you write flux? B into A. B we have to write because of this loop at this point. Okay, you get it. I hope it is easy for you to follow again. Let us go for the next question now. Next question is again on your mechanics. Here we are saying a tennis ball is dropped from 9.8 meter, it hits the ground and rebounds to 5 meter. Calculate average acceleration at point of contact, t is 0.2 second. That means this t must be given only for time of contact on the body. Okay. If I know the time of contact, what he is asking here, he is saying average acceleration. You know what is my average acceleration is nothing but what? My final velocity minus initial velocity upon the time interval, that is time of contact. This time of contact should definitely be here 0.2 second. V final is the velocity which is what is indicating V2 in this diagram. Let us say the body is coming and striking the surface with V1 in the downward sense. If I consider my upward as my positive direction and downward as my negative direction, so what we can say, this V1 should be negative, V2 should be positive. So I can say it is going to be what? V2 plus V1 upon delta t. That means in this question the only task is to understand what is my V2, what is my V1. That too is so easy. Here he is saying the body is dropped. Dropping means what is my initial velocity is going to be 0. Reaching to the maximum height here, maximum height means what? Velocity at the highest point is becoming 0 at that point also. The moment I am saying here is my velocity in the beginning is 0. At this point if it is writing, you can use because height is given to you. We can use my third equation of motion in a very simplest manner. I can say V1 is square here. So what is my V1 is square? See it? I can write my V1 is square is equal to U is square, body is coming in the downward sense. So I can write A is downward, H in the downward direction. So it is going to be 2G into H1. Isn't it? H1 is given to be 9.8. So if I write G value is not given, let us say it to be 10 only if I consider. So 2 into 10, let us say 10 will help us, or 9.8, it is going to be H is 9.8. If I write my V1, it is going to be this much. Okay, so it is 2 into 98 if I write, to 2 into 49 will make it easy for us. So under root of this is going to give you 72 is going to be how much? 14 if I am not wrong meter per second is my velocity with which the body is impinging with the ground, isn't it? Now in the second part what he is saying, the body is rebounding back and going to the maximum height of 5 meter. That too again is easy. If it is going to the maximum height V here, so again I use my third equation of motion, I can say what is my V2 square is, again I am using my final velocity square is equal to 0, V2 square minus 2gh. So I will get V2 square is 2 times g into the height, that is what the body is going, is 5 meter. What's the value? If I take it to be g as my 10 here, so this is going to be 10 into 10, and this simply says what is my V2 is going to be 10 meter per second. If my V2 is known as 10 meter, V1 is 14 meter, what is my average acceleration? So easy, isn't it? So V2 plus V1 is 10 plus 14, I can write now directly, 24, divided by time of impact is given to be 0.2. If I make it 0.2 multiplied by 10, cancel it out, here is going to be 5, and what is this value? 5 into 4, 120. See, so 120 meter per second or meter per second square should be your average acceleration. So 120 meter, that means B should be the right answer for this question. Okay, let us see the next one now. So in a dimensional analysis, okay, we should know the relations which can simplify these things. The first he is asking, match the quantities with the correct dimensions. Latent heat, electric field, pressure gradient, electric potential. All you know very well. Latent heat is nothing but what? My energy. But you know, in case of first, if I write my latent heat Q is nothing but what? Mass into latent heat. What is my latent heat here? So this simply says this L is equal to Q divided by mass. Q, you know, as I said, is energy. So what is the dimensional formula for energy? If I write my dimensional formula for L is going to be Q is equal to m L square T minus 2 divided by m is m. So that is simply is nothing but what? L square T minus 2. So L square T minus 2 is there anyhow. So what he is asking? Latent heat first of all. So okay, divided by m. So L square T minus 2, yes, it is there, S. So latent heat, that means first correspond to your option S. That means this is equivalent to S. So one is matching with S. Secondly, if you go for the electric field, now what is the easiest formula to decide your electric field with these M, L, and that you know F is equal to E into Q. From there if I write, so if I go for the second case, I write my electric field E will make it much comfortable because it is written in amperes, the F upon Q. But you know, Q is nothing but what? Current into time. So in place of Q, if I start writing my dimensional formula for electric field intensity, F you know is going to be ml into T minus 2, that is mass into acceleration, divided by Q. Q is nothing but what I am writing now, my charge, and charge is nothing but what? My current into time. Q is equal to IT. So I is Q upon T anyway. Here if it is what we are writing, it is going to become how much? So you just check it. M L T minus 1, rather minus 1, and is minus 3 here, and then A to the power minus 1. So MLT minus 3, is there any possibility? MLT minus 3, A minus 1 is given in P. So that means this goes with P. So 2 is going with P. So here 2 is going with P here. Is there any possibility here? 1 is going with S. Yes, 2 is going with P. So only if you check 2, we can get easily the answer is going to be S. But anyway, you try the next ones also. If I am writing this third, so third is going to be pressure gradient. Gradient is nothing but what? The variation of a quantity with respect to position. The moment I am writing my pressure gradient, so I can say yes, delta P upon delta Y or delta X or delta R, whatever you write, it is going to be my pressure gradient. Okay, for the understanding, I am writing my pressure gradient in this manner. Pressure gradient, you are writing pressure. Pressure is nothing but what? Force per unit area. Force you are writing is MLT minus 2 divided by area is L square. So this might be becoming pressure. Upon the distance, distance is nothing but what? L again. That is what if you simplify, what we are getting, it is L, L you eliminate, it is going to be M, L raised to the power minus 2, T raised to the power minus 2 is now my dimensional formula for pressure gradient. So do you see here any value you are getting? ML minus 2, T minus 2 is there, is Q, yes 3 goes with Q, so we can write 3 is going with Q. So here is this, it is going with Q here. Similarly, if you see the last one also, electric potential is the most simple one. Electric potential, how do we write the easiest formula? W is equal to work done is equal to Q into my potential difference. If you use this formula, it makes it much easy for you to get the dimensional formula for potential. I can write now potential or potential difference or potential. The dimensional formula for potential difference and the dimensional formula for potential is going to be same, because you know according to homogeneity of the dimensions, only those quantities can be subtracted or added which have the same dimensional formula. So if I write delta V, or even I write my dimensional formula for potential is the same value. So I can write now my dimensional formula for V is going to be delta W upon Q. Delta W already we said is energy, it is ml square T minus 2 divided by Q. Already we have written Q is equal to A into T. The moment I go with this A into T, what is my dimensional formula for V? It is going to be m L square as it is T minus 3 A minus 1. So A minus 1 T minus 3. Do we get anywhere? So what is left over here? So it is m L square A minus 1 T minus 3. It is going with R. That means first is the right answer for this. So A goes with 1 goes with S, 2 goes with P, 3 goes with Q, and 4 is going with R here. So that is what is the matching for this. Again, it's a simple one. So the moment if you remember the formula, you can go for the question. Go for the next question now. So here again is a very easy question on your radioactivity, this nuclear decay. So the nucleus undergoes 2 alpha decay and 1 beta decay. Find the atomic number and mass number, most simple one. What are you writing? Here you know alpha is nothing but what? Nucleus of the helium. So you know it is going to be 2 times He plus He4. That means in this alpha decay, mass number is decreasing by 4 and this atomic number is decreasing by 2 here. So what we are writing? X he is writing here, just see. This value is 236 and this value is given to be 92. If there is an alpha decay, that means what I can say, so in place of x now I write it is going to be y, suppose, okay, take it to be y, y plus what we have written 2 He4, that means there is a decay of this, so this has lost, is coming here, so this y is going to be how much? It is going to be 90 and this value is going to be how much? 232. There is another decay here, so 1 alpha decay is there. After 1 alpha decay, okay, I write now directly, it is going to be suppose Z here. If I write Z, then again you decrease by 4, it is going to be 2, how much the value? 232 is 228 and Z is going to become 88. It is 88 plus what you are writing, it is going to be 2 times He4. What he is saying, there is another decay here, that is our beta decay, that is beta minus. Okay, beta minus is nothing but what? Electron, you know well, it is nothing but what? If you represent it in this manner, it is like this. In this case, that means if I write the last one as this here, so finally your element is going to be, suppose I say P is my final product, that is going to be 228 will remain as it is, 228, but this is decreasing, that means it is adding here, so I can write it is going to be how much? 89. So what is my mass number is becoming 228 and my atomic number is becoming 89. So this again is the most simple question for you to answer. Okay, so that should be the C here. So let us go for the next question now. Next question is saying a wire has been made into a circle and placed in a constant magnetic field. If the radius of the wire starts decreasing at the rate of 2 cm per second, when wire starts shrinking, why starts shrinking means quite possible he is saying the radius is decreasing, that may be the case. Find the EMF induced in the wire when the radius of the wire is 10 cm. At the instant when radius is 10 cm, he is asking what is my induced EMF. Magnetic field strength in the region is given to be 0.8 Tesla, that's okay. Again, this is a question of electromagnetic induction. Here you know, one thing we should say, yes, you are maintaining the shape of the circle, it should remain circular only. So, but again, it is a memory based question, so what the students are saying, accordingly we are framing the language and writing, so there is some flaw in the language, no issue. So we are maintaining the circle shape, and if this is what he is saying, if there is a circular region and if I keep on decreasing this here, as he is saying the question, okay, constant magnetic field is constant, be careful, and if this word starts decreasing, that means the rate of decrease of radius is given to you. With what rate the radius is decreasing? Initially let us say the radius is going to be r, and when the radius is becoming r naught or r dash, this r dash is given to be how much in the question? 10 centimeter. At this stage he is asking how much is my induced EMF in this wire. Again, you know how to write my Lenz's law, I mean to say your Faraday's law is saying E is equal to minus times d phi upon dt. For the time being, if I write my magnitude only, I don't bother about my sign here. Sign is showing, you know, conservation of energy relations. So d phi upon dt, phi is equal to what you're writing, B into area d of dA upon dt. Area at any instant of time is suppose is going to be r. So what you're writing with it? You're writing it is going to be d upon dt, and the magnetic field remains B, which is what question is saying is constant. P into area is nothing but what? Pi r square for this circle. The moment we write this thing, what we are writing here, it is going to be B as a constant quantity, take it out. Pi is a constant quantity, take it out. R square differentiation is going to give you 2r into dr divided by dt, as I am differentiating it with respect to time. With what rate dr upon dt is changing is given to you, r is given to you, this is there. This is the value of induced EMF, that's what the question is asking. Simply substitute the values, I hope you should get your answers. What is my value of B? In the question is given to be 0.8. Now all of you can simplify this easily. Pi is what? No value is given. Okay, let me take pi as my 3.14 into 2 into radius is 10 centimeter. 10 centimeter converted into MKS system, it is, or SI rather, 10 upon 100 into dr upon dt. With what radius is changing is given the question. Dr is changing with the rate of 2 centimeter per second. I can make it as 2 divided by 100 here. So what's the value here? This is what we have to simplify. 0.8, okay, I divided by again 10 here. What is my value? 2 into 2 is 4. Approximately, I am just guessing my answers here. It is 2 into 2, 4. 10, you can eliminate 1, 10, no issue. 1000, 1, 2, 3, 4. 10 raised to the power 4 is the denominator factor. It is 8, 2 into 2, 4. 32 into 3.14. If it is 33, is nearly 100. So what you are writing? 100 divided by 10 to the power 4. That means approximately should be 0.01 volt. That means yes, so that A should be the right answer for this question. Okay, so again just using this induced EMF, with what rate my radius is changing, we should maintain, yes, my shape is maintained as a circular shape, so I can write always as pi r square. Okay, let us go for the next question now. Here what he is saying, two antennas has height 80 meter, what is the range to which signals can be transmitted? Simple. What is the way? How you are writing? Let us see. Again it is what he is not mentioning. I think it should be the line of sight propagation. If it is a line of sight propagation, it does depend on the height. So again, no problem. In the question originally, in the original paper, they must be writing it there. Okay, it is a line of sight communication system. In case of line of sight, you know, if this is what I consider is my earth surface. Okay, so it is the simplest question of communication. What you are writing? Let us say there is a tower of height h. If I consider my tower here of some height h, to what distance you can transmit the signals? That is what you can say. Yes, you draw a tangent here. Here, this is the distance up to which the transmissions or signals are transmitted. This is what you are saying is a transmitting, and here is saying this is a transmitting antenna and there is a receiving antenna also. He is saying in the question, transmitting antenna and the receiving antennas are of same height. Okay, let me draw a situation somewhat in this manner. That means this height is also going to be h here in this manner. So what he is asking, if this is h here, according to the radius of the earth is going to be r here, and this distance is d, that distance is also going to be d. So up to what distance the signals can be transmitted is going to be 2d. So ultimately what you are supposed to find, you have to find here the range to which signals can be transmitted is going to be nothing but I have to find the value of 2d. How do we find the value of 2d? It's simple again. If you use this simple calculations here, otherwise so many of you may be remembering the formula also, but if you want to write a bit of steps here, it is going to be r plus h, it is d, it is r only. So we can write now r plus h whole square, this distance is equal to d square plus r square, isn't it? If it is d square plus r square, it is r square plus h square. So we can write it is going to be h square plus 2 times rh is equal to d square r square. I am eliminating it out here. One more condition, you know, the radius of the earth is much larger because height is given to be only 80 meter, and in this question also they should mention the radius of the earth. Even, I hope all of you may be knowing this, radius of the earth is given to be 6400 kilometer. So we can write 6400 kilometer. In comparison to this height, h is almost negligible. Anyway, so that means h square can be omitted. So you replace, that means d is equal to how much? 2 times r h under root. Once I get 2r under root h, total distance is going to be 2 times of this. So what the question is asked? So I can write now, range of the signals transmitted is 2 times under root of 2rh. Now you substitute the values. I hope we should get the answer. 2 into r is 6400, answers are in kilometers, so let it be in kilometers, into h is given to be 80 meter. I write 80 divided by kilometer, I make it as by 1000 here. If I divide it by 1000, what you are saying, it is 0, 0, 0, 0, all is cancelling out. What is the value? It is going to be how much? 2, it is 2, and this is what you are writing, 8, it is 4 into 2, it is 32, 8. So 2 into 2 into 8 into, we have taken 2 into 2, this is the value. Okay. So what is the value? 2 to the 4, 4 into 2, 64. It should be 64 kilometer. Is the real option? Yes, quite possible. Maybe remembering the right options. So it is going to be 64 kilometer is the range up to which, using these transmitting or receiving antennas of the same height, the signals can be transmitted. This question is again from the rotational mechanics. A disk of radius r is given angular velocity omega naught, angular speed, and placed gently on the rough horizontal surface. Find the velocity of the center of disk when pure rolling starts. See, here if the body is rotating in the beginning, so this body, as you know, when the body is kept on the surface, the external force acting on the body is a normal reaction. If I redraw the diagram here, in this case, there is a normal reaction from the ground. There is a weight of the body, mg. As the body is given an angular velocity omega naught in this manner, so this point, lowest point, has a velocity in the left hand side direction, so there is a frictional force in forward direction, and that is going to be your kinetic frictional force. Since kinetic frictional force, normal reaction and weight, all of them are passing from this point of contact, so torque about the point of contact is going to be 0. So now since we say torque about this contact point, if I say C, torque about contact point is 0. So obviously your angular momentum about the point C is going to be conserved. So once we are writing this angular momentum is constant about point C. In the first case, once the body is given an angular velocity omega naught, that means it is going to get only a spin angular momentum. But once you keep the body on the surface, then spin angular momentum starts decreasing because of this omega will start decreasing because of frictional force torque. But frictional force will give you a translation motion. That means the velocity of center of mass will start increasing. A stage will be reached when v equals to omega r, then we say body will start following pure rolling. So at the instant of pure rolling, if I say what is the situation here, I can say my velocity of center of mass must be equal to omega into radius, if I consider this radius to be r here. And this body is having angular velocity omega. So again, if I write the angular momentum about this contact point, so now contact point is becoming ICR in case of pure rolling, but not in the beginning. So what is that? You can write conservation of angular momentum. I write L about C initial, and I write L about C, that is contact point, final. Final is again I about ICR into omega. It is L initial is going to be I about center of mass into omega. Initial angular velocity is given to be omega naught. He is asking what is the velocity of center of mass. So I have to find omega. We can find from there as velocity of center of mass omega r. So okay, I about center of mass, it is a disk, so we can say it is half m r square into omega naught. I about ICR is going to be 3 upon 2 times m r square into omega. What are you writing? mr square is cancelling out here, 2 is also cancelling out here. So what is my omega? Finally is going to be omega naught upon 3. If I write this linear velocity or velocity of center of mass, so V center of mass is going to be omega into r. That is what is omega naught upon 3 into r. So omega naught r upon 3 is the A is the right answer for this question. Okay, so these were the questions available with us as the memory based questions. That is what. So we try to discuss the maximum here. I hope you must have enjoyed and learning this way of solving the question.